Tulsa too, and then start going through fossils through the ages that we have in Oklahoma through various oceanic deposits. So we'll go on. So here's the geologic time scale, of course, starting Precambrian all the way to Cenozoic or current age. Most of our deposits are going to be in the Paleozoic. We are covered in oceans, actually tropical, surprisingly enough. We're near the equator through most of the Paleozoic, and that's where most of our rocks and fossils come from. We do have a little bit of Cretaceous and Cenozoic, but we were above water for most of that time next. So this is kind of a general view of Oklahoma. It doesn't really get into detail on this map, but of course you can see our mountains. The reds are the oldest rocks, the Wichitas and the Ozark, or the Arbuckles. You have younger rocks up in the northeast and the southwest, or the Washitas and the, Wichitas, the Washitas, the Ozarks, the Arbuckles. And so we have 4 mountain ranges, kind of keeps things interesting, and then you have the Nemaha Ridge, and we have some preservation way out in the Panhandle from volcanic activity as well. This is more of a specialized one. It actually breaks it down by age and formation. Again, the red, that's actually igneous rock that was uplifted, older rock, and as it gets lighter, you can see it get younger. Ironically enough, the red beds, the Permian red beds, are blue just because that's the color scheme, and then we're kind of in that purple-gray window there. Couple cross sections here, just so you can kind of get an idea of what it used to be. Along with the mountain uplifts, we had basins coincide. So you can see the first one is AA prime running across the top of the state. Just a little dip. Basically all the formations here are dipping down to the west at about 1 degree. Whereas you have B prime and C prime and the other two. You get to the southern half of the state downward near the older mountains, and it's a pretty deep basin. One thing I want to take from this, my professor told me it's one thing to always keep in mind: the present is the key to the past. The same processes we see today, we see throughout history. So you have all these different depositional environments that we can look at and apply back to the past. And this is actually where it gets interesting in Tulsa. You know, Tulsa's not uplifted, but we still have all these hills. Well, it's mainly due to differential erosion. So we'll have all these, reefs, deltas, river deposits that got buried over time, and then everything else filled in with shale. Well, the sandstone and the limestone is so much harder to erode, so that eroded away, and that's left us with our hills today. This is called a cyclothem. Basically, as the sea levels rose and fell, you have the sequence repeated over and over again. Again, this is what we saw in Tulsa. So the sea level would fall, you'd have rivers cut through the reefs, you'd have rivers cut through the sand dunes or bar sands, and then it'd get filled back up as the sea level rose again, and you just have this repeating sequence. This is why Oklahoma is one of the richest fossil areas in the world, oddly enough. But we also see these sequences in the stratigraphy around here, because we're all cyclothem deposits around Oklahoma, or this part of Oklahoma. So this is kind of the temperature cycles we've seen over the years and how it relates to our sea level change.
Again, bottom line says millions of years.
Yeah, this is so what's interesting, we're Pennsylvanian age. You can see that there right in the middle, ranging from about 360 million years ago to 250 million years ago. We went through a very quick sequence of ice ages. So we'd go through, having a mile-high glacier to quickly having almost nothing left. And this repeated over and over again, giving us our dense deposit of cyclothems. Also lending itself to the fact of why we have so many fossils here is that it was such a drastic change, it was unable to preserve enough material, lending itself to today. So paleogeography, that's the study where they try and take basically how they've mapped it back to where it was regionally. They've looked at the different environments, how deep it might have been underwater, what kind of fossils they find, and they use that to try and map what the world used to look at. There's a lot of interpretations, a lot of places you can look at them. Ron Blakey, I'm going to show you in a minute, just because I have a nice sequence of that. If you want to use your app, Earth Viewer is a good app that you can look at. It'll show you where you are and how it's interpreted in the past. Another good app is Rocked, R-O-C-K-D. It also tells you about the geology under your feet, fossils, papers, formation name, what have you, but it also has a paleogeography interpretation as well that you can scroll through for fun. All right. Oh, wrong one. So I'm gonna open this up real quick. So I'll just scroll through this real quick. I forget to do the bottom first. So here's how we were back in the, oh, it didn't transfer over. One moment.
How many of y'all's brains are blown right now? Just a little bit? Watching this, I'm like, I wasn't prepared for this today.
All right. So here's late Precambrian. It's what the U.S. kind of looked like back then. And you can come up and you can kind of see how the sea level would rise.
Yeah, hold it till we put out Oklahoma.
Yeah.
There's Oklahoma.
How long ago was that?
This particular map's 485 million years ago. So this is early Ordovician. Mid-Ordovician, late Silurian, and that was, yeah, so there was a massive ice age right here that was a major death. And come up to Silurian, then Devonian, and these two, especially around here, because there was so much erosion during this time, they get kind of mixed together as the Siluro-Devonian. But you can see the sea level fell, Oklahoma was exposed for that time, so we had a lot of erosion. Late Devonian starts filling back up, and we get the Mississippian. So this is kind of where most of our rocks start, Pennsylvanian. This is where Morocco kind of blasted into us and formed the Appalachian Mountains. So it's funny, if you go down the Arbuckles, you can go to a quarry and see a thrust fault. And that thrust fault here in the Arbuckles is part of the same event that created the Appalachians. So it's all kind of connected. Of course, then you get late Pennsylvanian, Permian, sea level starts to fall. And then generally from Permian on, we're above water until late Cretaceous. See things start breaking up, starts looking a little more like modern day, and then late Cretaceous you get the big seaway forming through the middle of the U.S. Unfortunately, we don't have much of that deposits left other than the south part of the state. It all eroded away. You do have a lot in Kansas and a lot in Texas, but the Oklahoma portion is largely gone. And then we've been above water basically ever since. So, yeah.
Peter, did you say Morocco bumped into Oklahoma?
Yes. Africa, yes. So it's funny, we have the same trilobites as Morocco does. They're just not as widely exposed. That's one of the big drivers there. But Cole County, Oklahoma, and that surrounding area around the Arbuckles, they find the same trilobite fossils as they do in Morocco. So Paleozoic, this is basically everything before the dinosaurs. It's Precambrian all the way through the Permian. So most of this time we were underwater, mainly shallow seas, tropical because we were near the equator. So here's just a picture from the Lake Cambrian. Where are we at? We're between the southern hemisphere and the Tropic of Capricorn. Again, mainly shallow seas, some deep water, and that largely depends on determines what fossils and deposits we have. Shale tends to be deep water or calm environments. Limestone tends to be shallower. Sandstone tends to be closer to a source, so maybe near shore. You want to go to the next one? Let's see. So saw a lot of course, Cambrian explosion. All the life started to come out. You have trilobites. You have all sorts of weird creatures, early sponges, crinoids, which are still alive today. Sea lilies. They had a little stem, and they're just a little filter-feeding animal, actually. And their stems are probably one of the most common fossils you'll find around here. Had a lot of other things. Those aren't necessarily from Oklahoma. They mainly are found in the Burgess Shale in Canada, mainly due to preservation, but you get Anomalocaris, trilobites, early Eurypterids, and soft-bodied creatures and jellyfish. So Ordovician, 485 million years ago to 444. Again, mainly tropical. Late Ordovician, we did fall into an ice age and sea levels fell because of it, and there was a large mass extinction event at that point. So see a lot of other weird creatures start to come out. Conodonts, they're still arguing over what it is, but you find those tiny, tiny, tiny little jaws. Like that's probably 60 times magnification there. Graptolites, cephalopods, straight line nautiloids, horned corals, other creatures. Let's see. Early brachiopods, starfish. Still trilobites are everywhere and getting sort of crazy shells, sponges, and fauna. So Paleozoic, as I mentioned earlier, I combined the Silurian Devonian, as most maps around here do, because the boundary isn't well defined due to sea levels dropping in the Silurian and erosion during the early Devonian. So they there's a conformity there. Again, mostly shallow seas. See Eurypterids during this period, they make a big appearance. Brachiopods, snails, clams, goniatites, gastropod snails, and then some crazy trilobites. You can see they have these big horns and feathery features that form during this time. We also saw early fish, early coelacanths, lungfish, ostroderms, early sharks that I always mess up when I try to pronounce that, Conrictes, I think, and Dunkelostis, which that picture is obviously old because now it's a lot chunkier from the current interpretation. Carboniferous is what's mainly relevant for the Tulsa area. Carboniferous is both the Mississippian and the Pennsylvanian, and we are entirely Pennsylvanian in the Tulsa area. So this ran from about 359 million years to 299 million years. Again, we're kind of in the southern hemisphere, a lot of shallow seas, and of course this is the time when we saw the massive swings in the glacial, or the temperatures in glaciers. So sea level would rise and fall dramatically, and that's why we got the cyclophyll deposits that we have today. So I have a lot of these items on the back table. I have a few shark jaws. I have an Adestus. I have part of the spine complex of the Stecanthus, which has this little anvil-shaped armament on the top of its head. Crinoids, of course, were still plentiful. We saw early reptiles starting to emerge, amphibians. Also have a couple other, I have a Campotis shark jaw back there, a large number of goniatites, trilobites and such that we can look at later. So, of course, there's Diplodocus, a whole slew of brachiopods outside of crinoids. Those are probably going to be your most popular item around here. Blastoids you can find in certain parts of Oklahoma, but they're mainly Mississippian. And then I just threw in the Thule monster, which isn't found here. It's famous for up near Chicago, out of the concretions there. But
Is it the one
it's
that looks like a tadpole?
kind of,
There's
or
that
no,
claw on the end.
yeah, it's the soft-bodied creature up there.
Yeah. Looks
Yeah.
like that.
You might have seen it on a U-Haul. They've thrown it on one of those. So Permian, we're kind of starting to dry up. The environment's changing, so we do have some marine deposits in Oklahoma, but largely we're either shallow marine or terrestrial. There's also a lot of chemistry changes during this time, and that's part of why we have the red beds due to all the iron content. Of course, there were a lot of lungfish. Coelacanths are still pretty prevalent. A lot more sharks. You still find bits and pieces of them. Helicoprion is that crazy tooth whorl. Then you had more fish and small reptiles and the such. But it is mainly dominated by plants and forests. Then the end of the Permian, Siberia kind of exploded, like in its almost entirety. If you've ever heard of the Siberian traps, that's where it comes from, is that it exploded and killed most of life on Earth. And then we get into the Mesozoic. So this is where dinosaurs come in. Triassic, Jurassic, and Cretaceous. Unfortunately, as I mentioned earlier, during most of this time we were above water. We do have Triassic deposits, but they're mainly river and lake deposits. They were only kept in place by the volcanoes erupting over New Mexico, covering them up and preventing them from eroding. I've actually been volunteering at the Paleo Lab at OSU and helping prep and look through microfossils from a Triassic site out in the Panhandle. But that's largely where our only Triassic deposits are left. So again, no real oceans. Same thing with Jurassic. We're above water. We're still shifting north in the northern hemisphere. Some it's mainly terrestrial deposits, some swamp and lake, but again, it's about the same. Not much is left from that time. Cretaceous, again, we did have that big seaway form. If you've ever gone to Kansas, you've driven out in the northwest part, you see the chalk everywhere. That's largely from the seaway. You had all sorts of sharks and other creatures show up. But we only have a little bit of that left in the southern part of the state. But you can still find ammonites and mosasaurs and other things like that. So here's just a depiction of that time. You have I think they called it's an Incudus, which I believe was called the fang-tooth herring or saber-tooth herring in the lower right. You have some ammonites swimming away from a mosasaur, some giant turtles, a plesiosaur, and some nautiloids in there too. You had free-floating crinoids. Of course, on the shores you had giant dinosaurs like giant gators like Sarcosuchus. There's another picture of Incudus, and then as basically through everything, you get the bivalves, the sea urchins, the gastropods, and such, all the shell creatures. You had this was the end of the crusher sharks, the hybodon sharks. One of the big ones was Tychotus. Their teeth are fun. They look like little fingerprint patterns on them, but they were pavement-toothed sharks that crushed the shells. And then you have Zephactinus, which if you ever go to Hayes or Oakley, Kansas, there's two museums there, the Fink Fossil Museum in anyways, there's one in Oakley at the library. The university in Hayes has a museum. The one in Hayes has a fish within a fish where it died eating the other fish, and both were preserved. But these things are about 10 foot long, so they're kind of crazy fish.
So that was a man supposedly in that picture.
Down up there on the left.
Yes, for the Tychota shark. A lot of sharks don't have as much preservation, so it's kind of, there's some rules of thumb they use based on what they do have. So shark sizes can vary a little bit, whereas bony fish like Zophaectinus, well, we have the whole skeleton.
Wow. Oops, sorry.
Cenozoic, that's everything since the meteor fell at the end of the Cretaceous up till now. We've had a number of hothouse and icehouse cycles, but we've been above water since then, so there's not really too much to talk about there, other than our river deposits where you can find mammoths and saber-tooths and stuff from the Ice Age, but not a whole lot.
Yes, you mentioned which I never considered, the proximity to the equator. Is that due to shift in the magnetic poles, or?
No, it's just the plates moving. So, plates would subduct, plates would expand like we have currently. You have the mid-Atlantic ridge, it's pushing apart, or you have others that are subducting. You have the new rift forming in Africa that's ultimately going to have a big channel form through half of Africa.
Because geographically, we were further south.
Yeah, we were further south.
Wow, okay.
We were tropical.
Yes.
What's the oldest rock considered in the earth, roughly?
Oldest rock, I couldn't say. Oldest fossils, oh no, I'm blanking on what those are. It's basically an algae colony found in Australia. Stromatolite.
So how far back would that go?
That one was pre-Cambrian. I'm going to say it was 4 or 5 million years old. Yes.
Is there any evidence of different changes in the world in the last 200 years compared to 2 million years?
In what way?
Well, it changed from water to land, right?
Well, the water filled up. You have, it's a whole combination of things. So you think of a different environment, you have a river delta. The river delta is bringing sand from upstream. Well, it's filling in whatever basin it can and expanding. You have, sea level will rise. You have more silt fall out. You have reefs build up barriers. You have uplift from continental plate collisions raising the land. You have plates pulling apart and sinking. Death Valley is actually a fun story. What was the California plate used to be a subduction plate. The plate broke off, giving us a strike slip now, and it just kind of melted there in the mantle and then did a flip. And all this super hot magma bubbled up from there and almost caused a rift valley. So that's where all that volcanism comes from. That's why there's some crazy geology out near Vegas, and that's why the elevation so low in Death Valley is that the crust almost melted apart there and became a rift.
Back to California, I thought it was amazing driving up I-5 out of LA to Tajon Summit, and you can actually see the San Joaquin Valley that once used to be an ocean.
Yeah.
Have you ever been there?
I have not.
I
been that
encourage
far
you.
west.
I encourage you to do it because it's quite a sight. Because you could see the entire valley. There used to be a sea here.
Mhm.
So is this the kind of evidence that people who deny climate change go to look at all the ebbs and flows of temperatures and water rising, etc.?
Well, that largely depends because there's not one consensus among any group. You have a lot of people that just aren't as worried about it. You have a lot of people that well, they're not worried about, sorry.
Yeah.
They're not as worried about because they can look at this and say, well, it's happened in the past. It's not.
Right.
It'll survive, and I mean the Earth will survive no matter what. That's not the question. But you have people that will, not look at anything. You have people that will make up their own stories. But I mean, it's a whole major system. It's hard to take into account every single variable. There was a study published recently where there's bacteria making a substance that actually helps cool the ocean that no one knew about or could trace before.
Wow.
So, a large group of people, it's not that they flat out deny it, it's they don't like the push from governments to bend over backwards for it. So it's hard to put everyone in a single bucket. But yeah, a lot of people will look at this and they'll say, well, it's happened before.
Were those more gradual changes though that we're
Some of them were
experiencing?
pretty rapid.
Oh, okay.
I mean, we're pretty rapid now too, but some of those were fairly rapid, but they had reasons to be usually. It's hard to pinpoint every single variable through the ages because you can find a deposit somewhere that will help support it, but a lot of that's been lost. If it was above the sea, it eroded away. So you don't have a full picture across the globe everywhere. We've had plates that have almost completely disappeared because they just got subducted back into the earth. And that's a whole part of the story that
You say fairly rapidly, but fairly rapidly is what? Millions of years, right?
could be, yeah, I mean, hundreds of thousands to millions. The ones around here were fairly, or a little more rapid than the others, just because, I mean, that's why we got the deposits we did. Everything would die off and become fossilized because it would get covered or uncovered as quickly as it did.
Very difficult for a human to live a maximum of 100 years to relate to that when that's millions of years.
Yeah.
In other words, you know, I'm thinking climate change, what the hell?
Yeah.
Close to 100, so, you know, I'm not gonna
Sweat it
Probably got time for one more.
Okay.
All this that changed over there was natural, right? It wasn't climate that caused it.
It wasn't man-made.
It wasn't, there was nobody to cause the difference, right? You feel now.
In which case?
Well, I mean, things happening to the earth moving.
There were no people, he's saying, so.
Yeah, well, I mean, there's no people back then, but you had, I mean, you had meteorite impacts, you had volcanism, you had the different setup of the plates and continents that would have produced very different ocean currents. So, you know, any little thing could cause a disruption and flip the script on you. I mean, it's not just one.
Those dinosaurs were big.
I mean, like right now, they claim that things that we do causes climate change.
No, we're not getting into that debate here.
I mean, what we do will cause an effect. How big an effect, we can debate until we're blue in the face. But, I mean, end of the day, do what you can. And you have to do it sustainably. You can't throw money at the problem and hope it goes away. You gotta actually have a cognitive plan to do something.
Well, I'm gonna have to cut us off there. I respect my time. That was wonderful. I'm sure we could ask questions 1,000 times over.
And if you
All of us,
have questions about anything in the back, I can go over anything with you. So.
yeah, that's wonderful. All I imagine during his speak, you know that big photograph of the Milky Way? And it has that little arrow that says you are here? I feel so tiny right now.
Yeah.
And normally I'm the biggest one in the room, so it's a little bit different. Thank you guys so much for coming. Peter, we would like you to draw our ticket for us.
All right.
Dan is bringing that up if you got into the raffle. I don't know if we announced that properly, so I apologize to our guests today. But Peter, if you wouldn't mind grabbing that out of there, then we'll do our four-way test and wrap things up.
Just one?
Just one. Read the last four numbers.
3986.
3986. Ah, Tom gets it today. Congrats, Tom. Thank you guys very much for coming, and for everything else.
No
What?
meeting for the next 2 weeks.
Yeah, no meeting for the next 2 weeks. January 7th will be our next meeting at Will Rogers High School. So please remember
What are you guys
that.
gonna do without me for 2 weeks?
Kendall, Mr. Baxter, we will not be here for the next 2 weeks, or January 7th. We'll be back, let me actually look it up right now, I got it right here. We will be back here on January 21st. And Stan is our Rotarian of the day. I'm gonna try and get that Habitat guy, unless you got someone else.
What about the 14th?
Oh, the 14th will be here.
Okay.
We'll get some people. Yeah,
So
for
we're
sure.
gone for 3 weeks, Greg.
Yeah, we got some neat stuff lined up. A lot of you have sent me some contacts for speakers next year, so we're gearing up for that to get that set up. So I'm really excited about the coming year. So Merry Christmas and Kwanzaa to you all. Happy holidays, and let's do the four-way test.
What do you say? Merry Christmas?
Christmas and Kwanzaa covers all of them.
Kwanzaa.
And then you can say Happy Holidays. All right, is it the
truth
Is it
fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned?
And will it be fun?
Well, you want to
Thank
find
you
out.
guys, the meeting's adjourned.